Outlier detection in Python. Welcome to this beginner-friendly lesson on outlier detection. Outliers are unusual data points that can affect your results. Learning to spot them helps you build better models and make smarter decisions. Running the cell now. Why do outliers matter? Outliers can make averages misleading, hide real trends, signal mistakes in data entry, help you find rare but important events. Detecting outliers is an essential first step when working with data. Running the cell now. We will begin by making a list of numbers. This list represents sample data like test scores or sales numbers. We will print out the dataset so we can see what we are working with. Running the cell now. Try changing some numbers in the list to see how the dataset changes. Now let us look at some basic facts about our data. We will count how many points there are. Then we will find the smallest and largest values. Running the cell now. What is an outlier? An outlier is a value that is much higher or lower than the rest. In our data, 100 stands out because most values are close to 12 or 13. Let us learn how to detect this outlier with Python. Running the cell now. The mean is a common way to describe the center of data. We are calculating the mean by adding all numbers and dividing by how many there are. We will print it so we can use it later. Running the cell now. The median shows us the middle value, which can be better than the mean when data has outliers. We sort the list to find the center. If there is an even number of values, we average the two middle ones. We print the median to compare it to the mean later. Running the cell now. Practice. Try adding a new small or very large number to the data list and see how the mean and median change. We subtract the mean from each value to see how far away each number is. This helps us spot numbers that are much different from the others. We use abs for absolute value so the distance is always positive. We print these differences for review. Running the cell now. We can spot outliers visually by plotting our data. This chart will show all our numbers as points in a line. Notice any value that is far away from the rest. Our outlier should be easy to see. Running the cell now. Try changing or removing the 100 in the data and rerun the plot to see how it looks different. We can make a simple rule to catch outliers. If a value is more than 30 away from the mean, we call it an outlier. We loop over each number and check the rule. The result is a list of outlier candidates. Running the cell now. Let us try letting you add your own number. We ask for your number, add it to the data, and print the new list. This helps see how the dataset can change with new values. Running the cell now. Let us see what happens to the mean and the list of outliers after we add data. We are finding the new mean. Then we use our outlier rule again. Let us see if your number changes which points are outliers. Running the cell now. Standard deviation shows us how much the data spreads from the average. A high standard deviation means values are spread wide. We are using Python statistics module to help with this. We print the number so we can use it for better detection soon. Running the cell now. A popular rule is that outliers are more than 3 standard deviations from the mean. If a value is farther than this, it is very rare. We use this method to catch unusual values in many fields, like science and economics. Running the cell now. Removing outliers can make your results more reliable. But sometimes, outliers are important facts, not mistakes. Here we make a new dataset with outliers removed. Running the cell now. Practice, see what happens if you remove different numbers or use a different outlier rule. What is the interquartile range IQR? IQR is another way to spot outliers. It looks at the range where the middle half of the data sits. Anything much bigger or smaller than most can be flagged. Running the cell now. The IQR method focuses on the middle half of data. We compute the first and third quartile, called Q1 and Q3. The difference between them is the IQR. Anything much smaller than Q1 or bigger than Q3 is an outlier. We print these IQR outliers for review. Running the cell now. A box plot is a simple chart that shows where most data lies. It also marks any possible outliers as dots. Let us make the plot so you can spot the outlier easily. Notice the difference from our earlier scatter plot. Running the cell now. Do not forget to like and subscribe if you find these lessons helpful. Let us try using real-world data. We will pull a CSV file from the web using the Pandas library. Pandas is a tool for working with tables of data. We print the first few rows to get a sense of what is inside. Running the cell now. Let us find outliers in the heights column from our table. We calculate the average and standard deviation for heights. We find any people whose height is more than 3 standard deviations from the mean. The result shows the outliers found in the real data. Running the cell now. For our mini project, let us write a function. The function marks every outlier with the word outlier. We use the 3 standard deviation rule inside the function. Then we print the result for our current data. Running the cell now. Here is a bigger challenge. We make a function that can use either the 3 standard deviation rule or the IQR rule. The user can choose the method by passing in a string. We print results using both rules to show how they can differ. Running the cell now. Common mistakes happen if you have missing values or data that is not a number. We make a new list that skips none and any value that is not a number. This cleanup step helps code run without errors. We print the clean data to check our filter. Running the cell now. If you see errors when running your stats, your data may include missing or non-numeric values. Always check and clean your data before running outlier detection. Running the cell now. Keep practicing. Let us know any issues in the comments and we will help. A great trick is to compare plots with and without outliers. You can see right away how outliers affect the data's look. This helps decide whether to remove them or study them more closely. The difference can sometimes be surprising. Running the cell now. Lesson recap. In this lesson you learned what outliers are and why they matter, different ways to detect outliers in Python, how to remove or mark outliers, how to handle common issues, that real datasets need extra care. Keep experimenting to build your skills. Running the cell now. Try it out and help others too. If you like this lesson, please like the video. Leave a comment sharing what you learned. Subscribe for more beginner Python tutorials. Share this with friends who want to learn Python. Practice finding outliers with your own numbers. Thank you for learning Python with us today. Running the cell now.